All right. Today, we're diving into something that it sounds impossible. It feels like it breaks the basic rules of physics that we all learn. We're talking about a puzzle that started with a high school student's ice cream project and has roots going all the way back to Aristotle. So here's the deal, and it's a total head-scratcher. If you put 2 cups of water in the freezer, one hot and one cold, the cold one should freeze first. I mean, it has less of a journey to get to freezing, right? It's just common sense. But what if common sense is just plain wrong here?
Well, believe it or not, the answer is sometimes yes, under just the right conditions. Hot water absolutely can win the race. And the modern story of this riddle, which we call the Mpemba effect, doesn't kick off in some fancy lab with white coats and beakers. Nope, it starts in a high school cooking class.
So let's get into it. Part 1. The schoolboy's icy discovery. This whole thing gets its modern name from an impatient student who just wanted to get his ice cream made. Okay, so meet Erasto Mpemba. Back in 1963, he was just a teenager in what's now Tanzania. He's in this cooking class, right? And like any teenager, he's a little impatient. So instead of letting his hot ice cream mix cool down, he shoves it straight into the freezer. And what he saw was just weird. His batch froze before everyone else's. He knew he was onto something.
So fast forward a bit. A physicist, a Dr. Dennis Osborne, comes to visit his school. And then Mpemba, he gets up and asks this question, the very one on your screen. You can almost imagine it, right? His teacher, his classmates, they're all kind of laughing at him. But Dr. Osborne, he wasn't laughing. He was fascinated.
And what happens next is just a beautiful story of how science should work. Dr. Osborne actually went back to his lab, ran the experiment, and what do you know? The kid was right. This whole thing ends with them writing a paper together in 1969, and just like that, a Tanzanian student's name is written into the history of physics. How cool is that?
But here's the crazy part. Erasto Mpemba might have given the effect its name, but he was far from the first person to notice this weirdness. Turns out, this puzzle is ancient. It's been bugging some of history's greatest thinkers for a very, very long time.
Yeah, you're seeing that right. We're talking Aristotle. Over 2,000 years ago, he literally wrote about this. Now, obviously, he didn't have a freezer, but he noticed that people would warm water in the sun to help it cool down faster at night. The exact same idea, hiding in plain sight for centuries.
And it wasn't just him. You've got some of the biggest names in the scientific revolution. Francis Bacon, René Descartes, Joseph Black. They all bumped into the same puzzle. Each one had a crack at explaining it, but nobody really nailed it down.
Okay, so if all these geniuses noticed it, why is it still such a debate today? Well, here's where things get complicated. A huge part of the problem comes down to a really simple question. What do you actually mean by freezing?
Think about it. Are we talking about the moment you see that first thin layer of ice form on top, or are we waiting until the whole thing is a solid block of ice? Because depending on which finish line you pick, your experiment's results can be totally different, and that little detail has made this thing a nightmare to study consistently. In fact, this thing is so tricky, so sensitive, that a lot of scientists trying to repeat the experiment just can't. They can't make it happen. You get studies like this one from 2016 that basically say, you know what? We don't think there's anything here. This throws a whole layer of doubt on everything. Is it even a real thing or just a fluke?
But okay, let's assume it is real. For the scientists who've seen it and believe in it, the big question is, why? How on earth does hot water overtake cold water in the race to freeze? Let's go through the list of possible culprits.
Yeah, there's no single aha moment here. Instead, we have a whole lineup of suspects. Scientists have pointed fingers at everything, from how the water moves around, to tiny gas bubbles dissolved in it, to the very way water molecules hold hands.
All right, suspect number 1, supercooling. This is a weird property of water. It doesn't always freeze at a neat and tidy 0 degrees Celsius. Sometimes it can get even colder while still being a liquid before it suddenly crystallizes. The theory goes that hot water doesn't supercool as deeply, so it starts the actual freezing process at a slightly warmer temperature, giving it a bit of a head start.
Next up, it's all about motion. It's called convection. You know how in a pot of boiling water, the hot water rises and the cooler water sinks? That's convection. Well, in hotter water, this process is way more vigorous. It's like the water has its own built-in super-efficient cooling fan, getting rid of its heat much faster, especially right at the beginning.
Then you've got a theory that's a lot less about physics and a lot more about the freezer shelf. Seriously, imagine the shelf has a thin layer of frost on it. That frost is an insulator.
You put a cold cup on it, and it just sits there, insulated. But you put a hot cup on it, it melts the frost right underneath, creating a little puddle. Now it has perfect contact with the cold surface, and it can dump its heat way, way faster. Kind of simple, right?
Okay, but just when you think you're getting a handle on this as a weird water trick, the whole story takes a sharp turn into the 21st century. This isn't just about your kitchen freezer anymore.
Lately, scientists have started seeing this same hotter cools faster behavior in all sorts of wild places. Yeah, in colloids, which is basically what Mpemba's ice cream was, but also in things like magnetic alloys, and even, get this, in quantum systems. This hints that maybe the Mpemba effect isn't just a quirk of water, but some deeper, more fundamental rule of the universe we just don't understand yet.
And just when you thought it couldn't get any weirder, it does. Scientists have now discovered something called the inverse Mpemba effect. And yes, it's exactly what it sounds like. Under the right conditions, a colder thing can heat up to a final temperature faster than a warmer one. I mean, that just turns your brain inside out, right? The mystery just keeps getting deeper. So, wow, after a journey that takes us from Aristotle's Greece all the way to modern quantum physics, where does that leave us? What's the final answer on the Mpemba effect?
Well, the honest verdict is, we still don't really know. The scientific community agrees that yes, the effect can happen. It's a real thing. But it's so frustratingly slippery, so hard to pin down, that there's just no single explanation everyone agrees on. It seems to be this delicate dance of many different factors, and we haven't figured out the choreography yet.
And I think this quote from the writer Philip Ball sums it up perfectly. Even if we finally solve it, we don't know what the answer will look like. Will it be something boring and simple we should have thought of ages ago, like the frost on the shelf? Or will it unlock something totally new and profound about how our universe works? That's the real question.
And really, that's what's so cool about this whole story. It all started because a curious student wasn't afraid to ask a dumb question. It's just such a great reminder that huge scientific discoveries don't always need a billion-dollar machine. Sometimes they just start with someone looking at the world, seeing something weird, and asking a simple question. Why? So what's the next everyday mystery that's going to spark a huge debate?